G actually spans quite a few different ideas. They're all decimal problems, and it's everywhere from addition to subtraction to multiplication to division. So we're going to see like a mixed bag in these. The first one, I'm going to write it horizontally like it's written here, and then we're going to deal with it. 8.5 minus 0.33. Okay. The thing about adding and subtracting with decimals, and you might remember this from when we ordered decimals earlier, was you want to make sure that when I can't do these horizontally like this. I have to have the numbers vertically in order to deal with them. So I'm going to rewrite that as 8.5 minus 0.33. And you might notice what I did was I put the decimals on top of each other. That way the common place values are together. This is not important with multiplication and division, as you'll see, but for addition and subtraction, you need to combine them because otherwise the place values are going to be a multiple of 10 off. So now you've got this, then you might ask yourself, well, this one doesn't have a hundredths place. Well, you can give it one, just call it 0. Bring the decimal place down, and then I think what the nuns used to tell me in Catholic school was just do the subtraction as if the decimal weren't there, which is exactly correct algorithmically, not so correct conceptually, but this is a math review, so hopefully the concept comes back to you. This one we're going to have to borrow from over here. This one becomes 10. 10 minus 3 is 7. 4 minus 3 is 1. 8 minus 0 is 8. And it's 8.17. Boom. Because you're taking 8.5 and taking a very little bit away from it. Okay. The next one is similar because it's addition where the last one was subtraction. So it's 0.0901 plus 4.34. I'm just going to go straight to writing it vertically. There's your 0.0901 and then 4.34. And then this one again is lacking some spaces, so I'm just going to put the zeros in there. And then we're just going to add straight down. 1 plus 0 is 1. 0. 9 plus 4 is 13. Carry the 1. 4. 4.4301. And I just realized we were told to round to the nearest hundredth place. This one already is. It's got 2 decimals. That's the hundredth place. This one needs to be rounded off to this place, which means it's going to be 4.43. So there you go with that one. Now the next few are multiplication and division. I'm going to group the multiplication together if that's okay with y'all, and then I'll group the division together. I think we've already done some division problems in this review already. Multiplication, I'm not sure we did. Oh, we just did, didn't we, with that 60 times 0.8. We'll do it again here. So 5.1 times 0.08. All right. Times 0.08. All right. I'm going to go ahead and line the decimals up with this one too. And then give you a 0 to hold the place there. The big thing about multiplying decimals by hand, and I'm not saying you should, I'm just saying I don't know if you're allowed to just simply plug this into a calculator. If you are, you're done. You get the decimal, you round it off. If you're not, we'll do it by hand here. Start with this bottom right one right here, 8. And then multiply it through everything across the top. 8 times 0 is 0. 8 times 1 is 8. 8 times 5 is 40. If there were non-zero things here, we would have to then start. Hang on. We'll get to one of those in a second. We'll get to one of those in the next example. Okay. But there aren't. Now all you have to do is take the decimal point, which starts out over here, and correct it for the number of spaces that are here. This one has 2 decimals. That one has 2 decimals. That means this one has to come over 4 decimals. So it's going to be 0.4080. But that's not rounded. The rounding, we have to go to the hundredths place, which is here. And that tells us to go up to 1. 0.41. So that's this one right here. 5.1 times 0.08. All right. We're going to do the next multiplication one now, which is the 5.5 times 2.5. This one's going to make a little bit more sense probably because this number is extraordinarily small, which is why this number came out being pretty small. The way that nuns taught me in Catholic school, again going back to my grade school years, were don't worry about the decimals at first with multiplication. We'll deal with them at the end. So pretend this is really 55 times 25. So 5 times 5 is 25, carry the 2. 5 times 5 is 25, plus 2 is 27. Okay, that's the first row. The next row, you put a 0 placeholder because this is over 1 place in the 20s place. 2 times 5 is 10, carry the 1. 2 times 5 is 10, plus 1 is 11. Add those two together. 5 plus 0 is 5, 7 plus 0 is 7, 2 plus 1 is 3, and 1. 1375. But the final result, you were assuming this entire time that the decimal was over here because you were ignoring the decimals. You now have to put the decimal places in. This is 22.5 is 10 times smaller than 25, and 5.5 is 10 times smaller than 55. So that means this whole number is going to be 100 times smaller than what it shows as 1375. So that's going to be 13.75, and that is already rounded off correctly per the instructions to the 100th place, because that's 2 decimals over. And I saw one more multiplication problem, and then we'll do the division ones. 82 times 0.2. Okay, 82 times 0.2. We have 1 decimal place to correct for at the end, because we're gonna assume that number is 2 and not 2/10. So the answer we get by ignoring the decimal is going to be 10 times too big, and we're going to pop the decimal over 1 to correct for that. 2 times 2 is 4. 2 times 8 is 16. That's 164. But it's not 164 because that decimal is assumed to be over here. This decimal makes it 10 times smaller, so it's going to be 16.4. So the reason you ignore the decimal and then bring it back is, you don't have to, but the nuns always showed me to do it that way because it's easier to multiply whole numbers using the rules you already know and then correct the final result when you're done by considering where the decimals are. So this one had to be corrected 4 places because of the 4 total places. This one had to be corrected 2 places, and that one had to be corrected 1 place. Cool. That was multiplication. Division, we've already done a couple of these, I think, in the previous problems when we had to convert fractions to decimals. So these are going to be similar. They look a little bit uglier, though. We've got a 4.2 divided by 0.8. 4.2 divided by 0.8. I can think of 2 ways to do this. I'm gonna do it the way I did it the first time. I was thinking if there's another way you can do it, and there is, but I'm not sure it's always going to be easier to do it that way. And again, I'm not even sure if you can use a calculator on these. So we're going to. This is the divisor. This is the number that's going in. So that's going to be 0.8 out here, and we're dividing it by 4.2. Now I don't know about you, but dividing by a decimal is kind of a pain. So what we can do, because remember this is actually a fraction, 4.2 over 0.8. We can make that just 8 on the bottom if we multiply the top and the bottom by 10. But that means we have to multiply this by 10 too and make it 42. 42 divided by 8. So this question here is really 8 divided into 42. And that doesn't have the kind of fear-inducing look that one does. How many times is 8 going to 42? Well, if you do your 8 times tables, it's 8, 16, 24, 32, 40. That's close. 8 times 5 is 40. So you go 8 times 5 is 40. Subtract, you get 2. Okay, so it doesn't go in exact. It's a little bit shy. So then what we have to do is we stick the decimal here and we give it a place of 0. Bring that 2 down. How many times does 8 go into 20? And 8 times 1 is 8. 8 times 2 is 16. 0.2. 2 times 8 is 16. Subtract again, we get 4. Another place, bring the 0 down. How many times does 8 go into 40? Aha! We know that one. It's 5. So 4.2 divided by 0.8 is 5.25. Follows the same exact algorithm we used before when we were converting fractions into decimals and percentages. Cool? Hopefully. And then we have one more of those to do on the next part of part G, which was 0.9 divided by 45. This one's going to be a little bit more hellacious. In this one, you had a large number divided by a small number, which came out with a larger number. This one, you've got a very small number divided into a larger number, which means that little small number is going to break into a lot of pieces. So we've got 0.9 divided by 45. 0.9, make sure I got that right. Yeah. 0.9 divided by 45. Okay, so this is the divisor. That's the one that goes out here. Divided into 0.9. Okay. Well, I'm already kind of stoked because this one doesn't have to be goofed with at all. This one's just 45, so we don't have to move a decimal point here. So I'm just going to leave the decimal here for, to keep it lined up like we did over here. But 45 can't go into 9, can it? No, it can't. So we have to give it an extra place. Can 45 go into 90? Yes, it can, exactly twice. And then you're done. Because 2 times 45 is 90 and there's no remainder. This is actually a little bit nicer than I thought it was going to be. I didn't think far enough ahead, y'all. So round it off to the 2 decimal places, which is exactly what that is 0.02. 2 hundredths, or 0.02. So that one actually was the nicest one of the entire batch, I think. It's the quickest one to do. And again, I'm going to say this one more time and I'm going to stop saying it. If you can use a calculating mechanism, these are simple questions. It becomes a rounding question at that point. If you're not using a calculating mechanism, which I don't think you can, these are the procedures that are always going to work for you.